the double feed induction generator. So here is double feed induction generator, this one feed and this one feed. Two double feed induction generator, and part of the return voltage goes to the grid. The grid here. Okay. Part of this one goes to the grid. I think is the equation. No video here. No video, I'm sorry. I thought some video. This one. So again, next lecture I will show you the video, the rotation of the wind turbine. Okay. So again, types of wind turbine. We say the horizontal axis and vertical axis. Okay, horizontal axis, but the blade is rotate as vertical rotation, and vertical. No, the blades rotate vertical, and the rotor is vertical. Okay, so it's different concept. Advantage of horizontal and vertical blade is horizontal is the efficiency of the horizontal is highest than vertical in open area, but in closed area or outside we can install vertical, okay, or on the street, on the highway we can install vertical, okay, rotate, and the rotation responds to the car direction, because when the car moves in one direction will generate some wind to rotate this one, and another side will rotate in this side, so still clockwise or anti-clockwise, depending on the situation. Yes. So, but the efficiency of the horizontal more than vertical wind turbine,
So
and the size more, the cost more of the horizontal. Okay. Yes.
well, I asked about the horizontal, it doesn't work at lower speed.
Yes. Not
Not
the lower. Okay. You need this page. It's just the concept of this one. Power generator. We say the wind energy conversion is the blade capture the kinetic energy and rotating the rotor. So this means the energy in the wind will convert it from the mechanical to the electrical. The energy converted the mechanical or the mechanical energy to electrical energy by the blade and the generator. Okay. Mechanical energy is transferred to the generator through the gearbox. We say why we need gearbox, because we need high speed at the generator. high speed at the generator, so we need to generate high speed, but at the wind blade, or at the at this location is low speed, maybe reach to 12 or 14, started from 12 their rotation, but it's low speed. Low speed, we can't transfer the speed from low to high using gearbox. Generator converts the mechanical energy into electricity, total on this one. Okay. Now, this one, okay. Now, this first part. Second part, the mathematical model and details. Now, we need to study the mathematical model. We give this sheet to the exam, to solve the examples and assignments. Okay. I think this just let me say this one first. Okay. Wind turbine formula sheet. You can use this formula sheet to solve the assignments or exam. Okay. First question, P. P is the output power from the generator, depend on the CP rho A V cubic. 0.5 CP power coefficient. Rho is the air density, kilogram per meter cubic. A swept area in area, so in meter square, okay, or in feet square, depend. But most books using meter square, okay. Wind speed, meter per second. Now, this area, Fahad said is area of the circle. Area of circle is pi times r square, where r radius or length of the blade. Okay, length of it, approximately, not exact same, but is difference is 10 centimeter or 4 inch, no problem. So this is blade equal to r. The length of the blade equal to r. Radius of the swept area. Simple. Now, V equal V naught times H divided by H naught power alpha. Let me this one. When the speed at hub high depend on V. V is wind speed at hub high meter per second. Speed at V naught, wind speed at reference height. Reference, this reference height, and this is hub height. Okay, so what the velocity at this one V naught, and velocity at this V. Sure, the wind is at V more than at V naught. Depend on the height. So this high and this high note, this reference high note, from this to this, from a table to this one. Okay, so H is height and reference height usually is 10 meter, is standard. Okay. Alpha is power law exponent. This is the exponent, the power of this term, H to H naught. Alpha depend on the, where is the installation of the wind turbine. Open water, smooth or flat or open land, okay, depend. So I will give you where you should install the wind. So install this one, select alpha this or this or this or this. Okay? As standard you can no mention in the example or in the question or assignment, select open land. Open land. Okay? Select alpha 0.14. Alpha here, 0.14. Standard. Okay? Because yeah, common use is alpha is 0.14. Okay? See here is different. If you select 0.25 or 0.1 for power, too much difference. Okay? So maybe I will give you, or no, if no, use open line. 0.14. I will give you, or it's open. Obviously, you can use this table. Now, tip speed W times R. Blade speed formula is typically the speed of the blade in meter per second. Omega is angular velocity or rotational velocity in radian per second. 2 pi f. 2 pi f. And R is the radius. Torque, we say that torque equal power divided by omega. Power, output power, and output power given by this equation. By this, same this. Okay, same this. Okay, so now torque equal power divided by omega, where T is torque in Newton per meter, Newton meter, and P power in watt, and omega radian per second. Now Cp equal P divided by 0.5 rho A V cubic. This is equation similar to this one. Same this one, just to calculate Cp, require Cp and given P. Okay, you can use this formula. This power coefficient formula. Unitless, no unit for this term. Gear ratio is the ratio between low speed and high speed. High speed at the generator side. Low speed at the rotor of the, or near the blade. The rotor of the blade. Lambda is the ratio between tip speed to wind speed. Tip speed to, we don't know, maybe more than one or less than one. Depend. Okay? We don't know. Depend. Because, see, no guarantee to get same air pressure, same air direction, or wind direction, or same wind speed. No, any guarantee to get it. Not same. So, for solar cell, no. We know in July, the sun is hot, okay? High temperature, high irradiance, so, okay, this is guarantee, but for the air, no guarantee. But sometimes, they give expected value, and load forecasting depend on the expected power generated from the wind turbine. Is average. If this year winter or in summer generated 100 megawatts as example, for next year and after next year, for next 10 years as example, we will take average 100 megawatts. This is not exact value, this is approximate value, okay? Even on the load forecasting and generating forecasting, not guaranteed to get same this 100, maybe less, maybe more than 100 megawatts, depending on the air direction. Maybe some building will add to the open area, so the air will be reduced and the air pressure will be reduced. So we don't know if lambda is more than 1 or less than 1. F is the force, F is the drag force, and CD is the drag coefficient, also unitless, and A cross-section area, F equal 0.5 CD A rho V square, no V cubic, okay? So this is not cubic, it's square. If we multiply by velocity, so this, the force converted to power. Force by velocity equal power. So if we multiply this one by the velocity given this one, if we suppose Cp equal to Ct, Cp equal to C, Cp and Ct are already given because this is standard for each unit or wind turbine. The efficiency is very important. The efficiency is the output to input. We have the output. We have the output. The output equation is given by this form. This form. This is the output. But the input is mechanical. We don't know the mechanical. So I will give you the efficiency to calculate the input. I will give you the efficiency to calculate the input power. Mechanical. Same idea for the generator. The generator is the output electrical power, but the input mechanical. We don't know the mechanical. Mechanical from prime mover. We don't know the prime mover power because it's mechanical. So given by horsepower or given the efficiency to calculate the input, depend on the question or example. Now, this last question. Any question about the mathematical model? Now, discuss the example of design, and next week we will discuss the power generated and power flow due to the generator or wind turbine generator. Okay, we will use fast decoupled load flow to calculate power flow in the transmission line. Okay, but not today. Next week. Today we will calculate just the wind power turbine calculations and design. Example 1, calculate the power output for the given parameter is air density rho 1.225 kilogram per meter cubic or cubic meter. Blade swept area or area equal 2000 meter square. Wind speed V, wind speed V, velocity, okay, in velocity, no voltage. V equal 10 meter per second and Cp unitless 0.4. Okay, we will use this formula. It's 0.5. Rho is 1.225 kilogram per cubic meter. So direct, you can use it. Then A, V is 10 power 3, 10 power 3 times 0.4. So equal 49 kilowatts. Any question? Very easy, direct, you can use the formula direct to calculate the output power. This is output power from the generator. Example 2. To calculate blade tip speed given rotor radius R 50 meter, rotational speed W 2 radian per second. You can use the tip speed by multiplying omega by R. Omega times R, omega radian per second times R 50 to tip speed equal 100 meter per second speed. So meter per second. Calculate Cp. Calculate Cp should be output power given, or maybe he will give you power input and efficiency. So calculate output power, then calculate Cp. He gave 30 kilowatt, air density rho 1.225 kilogram per meter cubic, blade sweep area 100 meters square, wind power 8 meter per second, wind speed, sorry, velocity 8 meter per second. So CP equal P divided by 0.5 rho AV cubic or cubic velocity. Power 0.5 from the formula, and this is rho area velocity, and this power free. So CP 0.45.
Is power coefficient related to efficiency, or it doesn't?
Here, power output. If he give you power input, should be give the efficiency and power in to calculate power out. Then use power out here. Okay? He will give you the efficiency maybe 95, because the efficiency of wind turbine high, 95, reach to 95, while the efficiency of the solar cell 25 or 26.
And the highest you said for solar cell, the highest is 27, right? The highest possible, the efficiency for
27, yes, yeah, maximum. Okay. So, but for the wind turbine, 95, but very expensive. It's very expensive. I cannot to install wind turbine anywhere, home or office or library, or because it's
and why the government they don't build?
the government, yes, can install.
But not too many, right? What I mean, let's say in Texas, how many percent from wind turbine is very small, right? Or
No, it's good for Texas. It's good, but
They have our animals.
Okay.
The direction of the wind,
Depends on the work, you cannot build it
space,
everywhere.
depending on the space, the one where you can get enough.
most turbine in Texas and west side.
in the desert,
Yeah.
About Tennessee and also Hawaii, they have.
Okay. Because high speed, high pressure. Okay. It's, if high speed is okay. Pressure is, and direction is.
But is it
You can-
consistently
Yeah.
rotating? Consistently rotating? It doesn't stop.
Yeah, constant.
It doesn't stop?
Yeah, yeah.
So nothing
Yeah.
stores the energy probably
No,
when
no.
it produces consistently.
Clockwise, anti-clockwise, depending on the design. It's already clockwise. Okay, so now the CP. Do you want to take 10 minutes break? 10 minutes break to complete the other examples and last section. Maybe at 7 we will finish. Okay. 10 minutes, right? Yes.
That one will show,
Yes, still this is not there. I will correct it. Okay? I'll post it and I will send you email.
okay, so don't need to worry about it?
No, no, don't worry about the, I just put the blank and then I will update it.
Okay.
Maybe this or maybe I, depending on your answer.
Okay.
No, yeah. That's what. Yes. It's different, yes, it's different.
Hold on. Take more. Like 5 or 10. Okay. You want to try some? Take some.
I'll
It's
take-
sweet.
I
You
don't
don't
like-
like sweet?
I might have to lie.
Oh. You went to the dentist?
No, I've had Invisalign